let's get right into it. Number 9. The Antimatter Riddle. According to physics, you shouldn't be here. Neither should this planet. Or anything. When the universe began, pure energy should have created equal amounts of matter and antimatter. Matter is everything you see and touch. Antimatter is its twin, with opposite charge. When matter meets antimatter, they annihilate each other instantly, violently, turning back into pure energy. In the early universe, if matter and antimatter were created equally, they should have wiped each other out. The universe should be empty, just leftover energy. No galaxies, no Earth, no you, but we exist. The universe is full of stuff. Where did all the antimatter go? The leading theory is unsettling. For every billion antimatter particles, there might have been 1,000,000,001 matter particles, just one extra. This tiny imbalance survived. That leftover 1 in a billion became everything. All stars, all planets, all atoms in your body. We are the universe's leftovers. Scientists are smashing particles, scanning space for hidden antimatter. But so far, nothing. Our existence is a cosmic glitch that allowed something to arise from what should have been nothing, and scientists have no idea why we're here at all. Number 8. Mysterious cosmic chill. Imagine the universe's baby picture with a massive bruise that shouldn't be there. Scientists call it the CMB cold spot. This baby picture is the cosmic microwave background, the oldest light, from when the universe was 380,000 years old. This ancient light is remarkably smooth, with tiny temperature differences, the seeds for galaxies, but scientists found a patch of sky way colder and bigger than it should be. Normal fluctuations are about 18 microkelvins. This spot is 70 to 140 microkelvins colder, stretching about 10 full moons across. So what could cause such a giant cold patch? The leading theory involves a supervoid, an unusually enormous empty space. Light from the CMB traveling through this void loses energy, appearing colder. But even if this supervoid exists, calculations suggest it's not big or empty enough to explain the entire coldness. Something else might be going on. One mind-bending idea is the cold spot could be evidence of another universe. Perhaps our universe literally bumped into another one, leaving this cold bruise. The cold spot remains a perplexing anomaly, challenging our understanding of the early universe. This massive cold spot continues to haunt astronomers, a chilling reminder that the universe is far stranger than we imagined. Number 7. Dying in the void. Movies show people exploding or instantly freezing in space. None of any of that is accurate. The truth is far weirder and probably more disturbing. You wouldn't explode. Your skin is strong. You wouldn't freeze instantly. A vacuum is a terrible heat conductor. You'd lose heat slowly. So what actually gets you? The lack of oxygen. No air pressure means no oxygen in your blood. You'd have 10 to 15 seconds of consciousness. Those 15 seconds would be horrifying. Air in your lungs would expand rapidly. Holding your breath would rupture your lungs. Exhale as much as possible. Then ebulism. Near zero pressure drops the boiling point of liquids. Moisture on your tongue, in your eyes, and lung lining would boil. Not from heat, but from lack of pressure. Astronaut Jim LeBlanc experienced this in a 1966 vacuum chamber accident. His last memory was saliva on his tongue bubbling. Your body would swell to maybe twice its size as body gases come out of solution. You wouldn't pop, just bloat. The Soyuz 11 disaster in 1971 saw 3 cosmonauts die when their capsule depressurized during re-entry from asphyxiation. If rescued within 90 seconds, you might survive without permanent damage. Beyond that, lack of oxygen to the brain causes irreversible harm, then death. No exploding heads or instant ice sculptures. Just a swift, brutal, and utterly alien end. Number 6. Spacetime's quantum foam. Zoom in on empty space. 1,000,000,000,000 times smaller than an atom, then 1,000,000,000,000 times more. What you'd find would make your brain melt. Space itself is having a seizure. Scientists call it quantum foam. Reality having a constant panic attack at the smallest scale. Like the ocean, smooth from afar but full of crashing waves up close, space works the same way. At the quantum scale, space and time are bubbling like boiling water on steroids. Tiny bubbles of space-time pop into existence and disappear faster than you can blink, creating and destroying bits of reality constantly. It's like the universe is glitching out at the smallest level, averaging out to create the stable world we see. Everything you experience is built on this chaos. Your reality is the average of countless microscopic seizures in the fabric of space. Scientists thought this foam might blur light from distant galaxies. NASA checked. So far, light looks clear, but that doesn't mean the foam isn't there. It just means it's even weirder. This chaos is happening everywhere all the time. Right now, between your eyes and this screen, reality is having billions of tiny seizures. Scientists lose sleep wondering what would happen if one of these quantum bubbles didn't pop. Perhaps a tiny glitch in space-time could suddenly expand and swallow everything. We don't know. Number 5. Silent space assassins. Imagine a cosmic sniper, thousands of light years away, that could wipe out life on Earth without warning. This is a gamma-ray burst, or GRB. GRBs are the most powerful explosions since the Big Bang. A GRB can release as much energy in seconds as our sun will in its entire 10 billion year lifetime. These are focused beams of intense gamma radiation from a collapsing giant star or colliding neutron stars. If a GRB from within a few thousand light years swept over us, we'd be in catastrophic trouble. And the freaky part is we wouldn't see the gamma rays coming. They travel at light speed and are invisible. No flash, just sudden, devastating consequences. The GRB would wage war on our atmosphere. Gamma rays would slam into the upper atmosphere, tearing apart nitrogen and oxygen molecules. These would reform into huge amounts of nitrogen oxides, creating a thick smog, blocking sunlight, and potentially triggering global cooling. But the scarier effect is the complete annihilation of our ozone layer. These nitrogen oxides would chew through it. Within months, much of the ozone layer could be gone. Without this shield, lethal UV radiation from our own sun would scorch Earth, damaging DNA, causing cancers, killing ocean plankton, and triggering a mass extinction. Scientists suspect a GRB might have caused the Ordovician-Silurian extinction 450 million years ago, wiping out 85% of marine species. While the chances of a GRB hitting us are low, it's not zero. And because we can't predict them or see them coming, it's like living with an undetectable cosmic death ray that could sweep over us at any moment. Number 4. Wandering black holes. Imagine a cosmic cannonball, millions of times heavier than our sun, silently hurtling through the galaxy, completely dark, completely invisible. These are rogue black holes, cosmic wanderers, not anchored at a galaxy's center. How does a black hole go rogue? Sometimes, an asymmetrical star collapse kicks the newborn black hole into space. Other times, colliding galaxies eject their central black holes like stones from a slingshot. You can't see them, black against black space. Astronomers spot them through gravitational microlensing. If one passes between us and a star, its gravity bends the star's light, making it briefly brighten, then dim. Hubble found evidence of one 5,000 light-years away. Estimates suggest up to 100 million wandering black holes in our Milky Way alone. So what's the danger? If one cruised through our solar system, it wouldn't necessarily suck up Earth. More likely is gravitational chaos. Its immense gravity could scramble planetary orbits. Earth could be ejected into the cold, dark abyss, or nudged into the sun. Even a distant pass could perturb the Oort cloud, sending a devastating comet shower towards us. And the scariest part is we wouldn't see it coming. A silent, invisible arrival. By the time we realized, it might be too late. Number 3. Universe fades to black. Imagine the end of everything. Not a fiery explosion, but a slow, silent fade into complete darkness. Scientists call it the heat death of the universe, and it's probably how everything ends. The universe is expanding, and it's speeding up. An invisible force, dark energy, is pushing everything apart faster and faster. So what happens when this goes on for trillions of years? First, galaxies drift so far apart they can't see each other. Future astronomers will see a completely black sky, their own dying galaxy floating alone. Stars don't burn forever. They run out of fuel. Eventually, every star will die. No new stars will form. The universe becomes a graveyard of dead stars, black dwarfs, neutron stars, and black holes. Even black holes evaporate through Hawking radiation, shrinking until they vanish. If physicists are right about proton decay, even atoms fall apart. What's left is a cold soup of loose particles, drifting aimlessly in an ever-expanding void. This is the heat death. All energy spreads out evenly. No heat differences mean no work, no movement, no processes, no life, no thought, just eternal, unchanging stillness, barely above absolute zero. The universe just stops. Everything that ever was, everything that ever will be, ends in cold, dark silence. Number 2. Universe tears apart. The universe is expanding, but that expansion could go completely haywire. Scientists have a theory for this end. The Big Rip. Dark energy makes the universe expand faster. In the Big Rip scenario, this dark energy, phantom dark energy, gets even stronger. The expansion becomes all-powerful. First, 60 million years before the end, galaxies would be torn apart. Then, about 3 months before the rip, solar systems become unbound. Earth would fly off into darkness. Just 30 minutes before the end, planets, including Earth, would explode. In the final tiny fractions of a second, expansion overcomes forces holding atoms together. Electrons stripped from atoms. Atomic nuclei torn apart. You'd witness your own disintegration. Molecules pulled apart. Finally, the very fabric of spacetime itself would rip apart. The universe would just break down. The idea that everything, down to your very atoms, could be shredded by the universe itself is a disturbing thought. Number 1. Space's terrifying silence. Think epic space battles in movies. Gigantic explosions, lasers zapping, thrilling. It's also a complete lie. Space is, for the most part, utterly, terrifyingly silent. Sound is a vibration needing something to travel through. Air, water, a solid. But space is an almost perfect vacuum. No air, no significant molecules close enough to pass vibrations. So, if a star 10 times our sun's size exploded next to you, you'd hear nothing. You'd see an unimaginable cataclysm, blinding light, but the soundtrack would be absolute zero. Imagine an astronaut on a spacewalk. Radio cuts out. Untethered. Drifting. They could scream, shout, bang on their helmet. Vibrations travel in their suit's air. But beyond that, nothing. Their terror, desperate cries, swallowed by infinite, indifferent silence. No one would hear them. Not the ship meters away. Not a rescuer. It's not just quiet. It's an absence of the possibility of sound. This profound silence amplifies space's terrifying scale. You're a tiny, fragile speck in an immeasurable void. This is the universe hitting the mute button on your entire existence. That silence is louder than any scream could ever be. That's all for today. I'll be making similar videos in the future. Subscribe to see them.